Hi everyone. In this video, what we will see is we will find out something called a splitting method to find the zero of the polynomial. So, splitting method. In fact, we need to actually look at something called method of splitting of middle terms, right? What does that mean? Let's take an example. So here we have got an example called 2x square minus 8x plus 6. Now, how do we find the zero of this polynomial? I already know what is the zero of this polynomial. If I simply move it to the right side of, if I simply move it to the right side of this, why do I do that? Okay, right side of this, and then solve it using something called formula method, which we already know. We know that given any polynomial ax square plus bx plus c, we know the roots are going to be equal to, or in other words, x is going to be equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So if you plug them into this formula, we will get here what we have here is the a value is 2, b value is minus 8, c value is 6, correct? So you put them here, so you get minus of minus 8 plus or minus square root of b square is 64 minus 4 into a value is 2, so 2 into c value is 6, so that divided by 2a, 2 times the a value is 2 again. So therefore that's going to be plus 8 plus or minus square root of 64 minus 4 2s are 8, 8 into 6, which is 48, right? So 64 minus 48, how much is that? 14 minus 8, which we have got 6 again, 5 minus 1, 16. So that's 16 divided by 4. Hopefully you remember that we have solved this problem in the previous lecture, which is 8 plus or minus 4 divided by 4, and that's going to be equal to, remember this is 8 plus 4 divided by 4 comma 8 minus 4 divided by 4, correct? That means we will get 12 divided by 4 comma 4 divided by 4. That means we get 1 4s are 4, 3 4s are 8, 3 4s are 12, so 3 is 3, 1 1, so this is 1. So we know that the roots are going to be 3 comma 1. So how are we going to obtain the same thing using something called splitting method? Okay, how are we going to do that? Let's keep that aside and we'll work on this method. So I know that the p of x, let's call it as p of x, then the p of x can be written as 2x square. Now I'm going to split only this middle term, okay? What I wanted was this particular middle term can be split across two different middle terms, in which I can actually plug them this x as well as its coefficient in a right manner. For example, what I'm saying here is, let's say suppose I split them into minus 2x minus 6x. You know that the minus 8 can be written as minus 2 plus minus 6, correct? Therefore, we can write this minus 8x as minus 2x minus 6x and plus 6. Now, what we can do because of this, what we have here is, let me change the pen color to something else. Because of this, what we can do is, we can club these two people. In a way so that I can take this 2x and 2x outside from this, and then probably minus 6 outside from this, so that I'll get something else is also common. Okay, don't worry, it comes in practice. So here I'm going to take 2x outside, and that's going to give you just x in the first term and then minus 1 in the second term, right? Hopefully you understand that. Now here another one is, we have got minus 6x plus 6. Now we'll put the plus here and we'll take the minus 6 outside. So we'll get minus 6 outside, and so this one will give you simply x, and this one will give you minus 1. Complete that is understood. Why is that so? Because plus 6 is something like minus of minus 6. So we take only that minus 6 and it leaves minus 1 in the back. That's the idea. Now because of this, what we have got, we also had one more term in common. So here we see that the x minus 1, here we see that another x minus 1. Now remember, this is in terms of the plus. So the way you think about it is actually think about it into two different terms, which are in the addition, where x minus 1 is in the product with the first term, and x minus 1 over here is also the product with the second term. So what we can do, we can pick up this x minus 1 is also outside, right? So we can do that as well. So x minus 1 times, now what is remaining in this term? The remaining is actually 2x, in fact the factor remaining, and here we have got minus 6. So let's write minus 6 as it is. So what we have got p of x actually has been written as x minus 1 times 2x minus 6. So we call this as a factorization. In other words, we are trying to write a quadratic polynomial over here in terms of a couple of linear polynomials. And it does happens for every quadratic polynomial that you take. You can always write any quadratic polynomial as product of two linear polynomials, provided if the roots are going to be a real number. Don't worry, in your class all the roots are going to be real number, as long as if you are not specifically asked for discriminant or something else. Okay, fine. So for you, what you can always think about it, you can always try writing it as a product of two linear polynomials. Now because of this, what we have got, now what we wanted to find? What we wanted to find was, we wanted to find the x values so that p of x is equal to 0, because we wanted to have the roots of this polynomial, correct? Okay, we already have got p of x is equal to x minus 1 times 2x minus 6. Now this is equal to 0. Now imagine what happens here. What happens here is, if at all two numbers are actually is product, two numbers are already in product, and then it gives you 0, what does that mean? That means either one of them should be 0, correct? Why? Because you see 2 into 3 will give you 0, will not happen at all. But if this has to be 0, either in the place of 2 I should get 0 times 3, then only you will get 0, or in the place of 3 I should get 0. That means if two numbers a and b are giving you 0 means, then any one of them must be definitely 0. That is the idea. So therefore here, if the product of two people like this is giving you 0 means, either x minus 1 should be 0 or 2x minus 6 is 0. That's the idea. And that means either x must be equal to 1 or x must be equal to, in fact 2x must be equal to 6, and hence x must be equal to 6 by 2, which is 1 2s are 2, 3, 3, which is x equal to 3. So that means what we have got, either x must be equal to 1 or x must be equal to 3, so that this product is going to give you 0. In other words, for the values x equal to 1 and x equal to 3, p of x is going to be 0. I know that these are the zeros of the polynomial, right? So this implies the zeros of p of x, whatever we have got, or 1 and 3, because these are the only two values which can make this product as 0 in either cases. Okay, fine. So that's all for this video, and I will see you in the next video.